Welcome students. We are discussing some numerical problems from the chapter machine. These problems have been taken from Conscience Physics book class 10 ICSE. So coming to the problem number 1, what is the problem 1 saying? That there is a block and tackle system having a velocity ratio equal to 3. So first of all, let us consider the diagram or to draw the diagram of the system indicating the point of application and direction of the load and effort. Okay, so for a block and tackle system, the velocity ratio is actually equal to the number of pulleys. So for this we can actually, if we just draw the diagram, what will be the diagram like? Let us just draw the diagram. So velocity ratio 3 means that the number of pulley will be equal to the velocity ratio. So actually for a block and tackle system, n is equal to the velocity ratio, and here the velocity ratio has been given as 3, where n is the number of pulleys. Now so if we consider 3 pulleys, now that in block and tackle system there can be two arrangements. One is one where there are even number of pulleys and one where there are odd number of pulleys. Here there are odd number of pulley. We know that for odd number of pulley, the upper block will have one more pulley than the lower block. So for this we can draw the diagram like this. So this is one pulley, this is another pulley. Okay, the circle, just let me draw it. Okay, so this is another pulley. So these are the two pulleys. Okay, fine. Now what is the next pulley? See, if I consider the next pulley, it will be in a separate block, isn't it? So considering this to be the one block, okay, so the block is formed like this. Okay, here is one axis point, here is one axis point. Okay, fine. And this is connected to the rigid support on the above. Okay, so let us just consider the rigid support here. So this is the rigid support, here the system has been fixed. Okay, and the other pulley will be connected to the lower block. It will have a separate block like this. Okay, and it will be having the block like this. Okay, here is a point. Fine. Okay, now how will be the strings be moved? Just note it carefully. If there are odd number of pulley, the string will start from the lower block. Okay, so if I consider the lower block, it will start from this point. Okay, from here the string will be rotating like this, then like this, then like this, and then it will come down. Okay, so this is the rotation system. If there are even number of pulleys, remember the string actually starts from the upper block. Okay, fine. So this is the diagram. Now you have to show the effort and the load, where the effort and the load applied. So the load is actually hung from the other end. Here is the load attached, here is the load attached. So this is the load, this is the load L. Okay, so it acts in downward direction. And if I consider the effort will be applied at this point. So effort is applied at this point. This is the effort. Okay, fine. So the load acts in this direction, downward direction. Okay, if I consider the tensions in the string, so here there will be, since the string is same, the tension throughout the string will be same, only the directions at different points will be different. So here will be another tension T, here will be another tension T. Okay, so these are the tension points. Fine. Okay, so this is the diagram. So I think the diagram is clear to all of you. Okay, now what is the other question asked in the problem? So we have drawn the diagram, shown the directions of the load and the effort. Now it is said that man can exert a pull of 200 kg. So I can say that the effort applied by the man, so in other words I can say the effort denoted by the letter say E will be equal to 200 kgf. Okay, if I consider this into convert this into Newton, I have to just multiply it with the value of G, 10 meter per second square. Okay, so if I do not convert, that will not be a problem. We will get the load in kgf. So it is said what is the maximum load that he can raise with this pulley if its efficiency is 60%. So if the efficiency denoted by the letter eta, it is given as 60%. Now first of all, from this, when you want to find out the load, we have to first of all find out the or determine the value of the mechanical advantage. Now remember one thing, we know that the formula ma is equal to eta into velocity ratio, isn't it? So this is the formula for the mechanical advantage, okay, isn't it? Now to calculate the mechanical advantage, hence ma is equals to efficiency is 60%, so I can write 60 by 100 into velocity ratio is 3, so into 3, okay, so this cancels out, 3 into 6 18, so it's 18 by 10, okay, so this is the mechanical advantage. Now according to the formula mechanical advantage, also know that mechanical advantage is equal to load by effort, so you can also write again we can write ma equals to load by effort. So we know the effort, we have to find out the load. This implies that we can write it as, okay, we can write it as, or ma is 18 by 10, isn't it? Okay, what is the value of the load, we have to find it out, and what is the value of the effort, it's 200 kg, okay, so 200, fine. This implies that load is equal to 200 into 18 by 10, so this 10 cancels out, 2 18s are 36, 10, so 360 kgf. This is the maximum load that the person can raise by applying an effort of 200 kg, okay. So I think the solution is clear, isn't it? Okay, so this is the solution of the first part of the problem. So you can raise a maximum load of 360 kg. I think the solution is clear. Okay, now that is another part, I think second part. So this was the first part, let me just mention this is part 1. So this is part 1, okay. And now what does the part 2 says? If the effort end moves a distance of 60 centimeter, what is the distance does the load move? Effort end moves a distance of 60 centimeter. Sorry, what is the value? 60 centimeter, yes. So part 2 of the problem is given as, so distance moved by the effort, it is actually 60 centimeter, okay. Then we have to find out what distance the load move, okay, fine. So we know that velocity ratio, what is the formula for velocity ratio? Velocity ratio is, as we know, is distance moved by the effort by distance moved by the load. So to find out the distance moved by the load, so velocity ratio has been given as 3, there are 3 pulleys, hence the velocity ratio is 3, so 3 is equal to 60 by dl, or in other words this implies that value of dl is equals to 60 by 3, that is equals to 20 centimeter, okay. So I think the problem is clear. So the value of the distance moved by the load is 20 centimeter. So this is the solution, okay, fine. Now let us move to the question number 2, okay. So solution 2, okay, fine. Now you are given a 4 pulley and 3 strings. So 4 pulley and 3 strings. Now see, we have to draw a neat level diagram to use them as so as to obtain a maximum mechanical advantage equal to 8. So how can you draw this diagram? First of all, see, there are 2 arrangements of combining pulleys. One is the block and tackle system, and another one is using a single movable pulley, single fixed pulley with a number of movable pulleys. So these are the 2 arrangements, okay. Now which arrangement do we have to draw here? First of all, see this particular word, 4 pulleys and 3 strings, isn't it? So there are 3 different strings. Even a block and tackle system, you have seen that there is only 1 string, isn't it? So if I have 3 separate strings, definitely this is a combination of a single fixed pulley with the other 3 as movable pulley. So what will be the diagram like? Okay, so let us quickly come to the solution, okay. So let us draw the diagram. First of all, there is a rigid support like here, okay. Just draw the support, this is support point, okay. Now let us draw the pulleys. So first of all, let us draw the single fixed pulley. This is a single fixed pulley, isn't it? Okay, so it has been hinged to the support point like this, okay. It is hinged to the support point. so it has been fixed here. Okay, so this is the first single fixed pulley. Okay, now there are 3 other movable pulleys, so it will be something like this. This is another movable pulley. Okay, this is another movable pulley. The frame will be something like this. The string, so here we will utilize one string. This goes like this and this goes like this and this. Okay, fine. Now let us draw the second movable pulley like this. It will be like this. It will have the axis frame like this. Okay, the other string comes like this and it is attached to here. Okay, now the third pulley, this is the third pulley. Okay, fine. So just let me extend this. The string will be coming through this point, it will rotate here and it will connect to this. Okay, so in this way the 3 strings are connected. Okay, and the load is attached to this point. Okay, so this is the load. Fine. Okay, and the effort has to be applied at this point, at this end. So this is the effort. Now where do the tensions work? Now there are 3 different strings, so there will be 3 different tensions. Then tensions will not be the same. So if I consider this string as T1, so this is tension T1 and this is tension T1. This is tension T2. This is tension T2. This is tension T3. This is tension T3, and here will be tension T3. Okay, so this is the arrangement. Fine. Okay, so I think the diagram is clear to all of you. Okay, see, how can you see? It has been mentioned that there will be maximum mechanical advantage of 8. So how can you obtain 8 mechanical advantage using 4 pulleys? Only if I consider one single fixed pulley with other 3 movable pulleys. We know for this kind of arrangement, the mechanical value of the mechanical advantage is actually, here the mechanical advantage actually is 2 to the power n, where n is the number of movable pulleys. So 2 to the power 3, that is equals to 2 to the power 3, that is equals to 8, isn't it? So I think the concept is clear, how you have identified this diagram. Okay, now let us come to the second part of the problem. It has been said, if the efficiency is reduced to 64%, find the new value of the mechanical advantage. Okay, so for this kind of pulley system, the velocity ratio is also equal to 2 to the power n. So 2 to the power n, here it will be 2 to the power 3, that is equal to 8. Okay, now we know that MA is equals to efficiency into velocity ratio. The efficiency reduced to 64%. Then what will be the new mechanical advantage? Okay, so it will be something like this. So it will be 64% means 64 by 100 into velocity ratio is 8. So into 8. Okay, so how much it turns out to be? Let us see. 425 and 4 to the 8. So it is turning out to be 128 by 25. So it will be something like this. How much will be its value coming out to be? 128 by 25. Now 5 5s are 125, so 5 something 5 and then 3 dimensional, so it will be coming out to be 5.12. so this is the value of the new mechanical advantage. Now you can consider that the mechanical advantage is nearly 5.12, so if we just consider it approximately, the value will be 5. Okay, so this is the value of the new mechanical advantage. So I think the concepts are very clear. So we will be ending the chapter machines here. We have done some numerical problems. I think the concepts are clear. If you have any doubt, you can mention in the comment section, and if you have any doubt regarding a particular problem, you can definitely mention that in the comment section. We will be solving that problem, specific problem for you. Okay, so we will be ending our class here. See you in the next class. Thank you.